So what do I mean by like a more complex rational function? Well, something like this. Oh, the quizzes, right. Shoot. I'll get those to you at the end of the class then. We'll do that then. All right. So let's take a look at this rational function right here. Okay. It's got a little bit of a different kind of flavor to it than the stuff we've been looking at, right? Okay. Most of the stuff we've been looking at, all right, has had like linear polynomial in the numerator and like a linear polynomial in the denominator. You know what I mean? So like, let's see here. For example, like this. Okay, we graphed this, or we talked about graphing this yesterday, right? That's a linear polynomial, right? If you graph just this polynomial, it would be a line. If you graph just this polynomial, it would be a line. And then we divide them, right? And so that makes it rational, right? Here, this is like a very simple linear polynomial, I guess you could say, right? 1, and then, well, then that too, okay? But now here we've got these two things multiplied together. It's quadratic, okay? So it's going to, complicate things a little bit more here. All right? But all I want to talk about for right now for this is, what is the domain of f of x? Okay? Now, what are some ways, or what's a way that we can figure out what the domain of this function would be? Well, first of all, when I ask you what's the domain, that means we're looking to describe what? The x values, right? Okay, all the possible x values that would be okay in this function. Okay, so what's one way we could try and figure out what the domain of this function is? Yeah, we could graph it. Okay, one option is we can just graph this thing. So let's graph it. All right, and see what we can see here, right? So to type this into our calculator, all right, we need to be kind of careful here. I would always encourage you with these rational functions to put parentheses around your numerator and parentheses around your denominator, okay? So parentheses around the numerator, parentheses around the denominator. And in fact, I would really encourage you guys all to try typing this into your calculator, because this is, if you can't type it in correctly, you're going to have, problems then when it comes to like graphing these and stuff like that. This also arose for some of you in your quiz/tests too, where you typed things incorrectly in the calculator because you didn't close off the square root or something like that, and messed up some of your answers and things. Okay, so it's super important that you can use the calculator correctly. Okay, so long story short here, how do we type this in? Again, I would suggest using this parentheses you see, but also putting one more extra set of parentheses around the numerator, and then of course put a set of parentheses around the denominator too. So I'm going to say parenthesis x plus 5. Okay, and then parenthesis x minus 1, okay, and then close that. So you can see what I've got right there right now. There's my numerator, right? And then I'll do divided by parenthesis x plus 1. Okay, so I have the x plus 5 times x minus 1 in a set of parentheses, then division, then a set of parentheses around the denominator, x plus 1 there. And we'll graph it.
Whoa. After the division, Sean put 2 parentheses?
So after the division, you only need to have one set of parentheses around the x plus 1 there. If you want to do 2, that's okay, but that's not yet. You don't need to do that. Okay. So here's our function. Okay. Does this function? Well, so what do you think the domain's going to be here? What's the farthest left we're going to go?
Infinity.
Yeah, negative infinity, I would say. Yeah. Negative infinity. Okay. And then, are we going to have any problem x values? Are there going to be any x values that we exclude, or are we just going to keep going to positive infinity here?
0.
So you're just going to keep going? Well, doesn't look like we have like a vertical asymptote right in here somewhere?
Yeah, 1.
Okay. Well, not positive 1. Negative 1, right. Okay, yeah. So we're going to go from negative infinity to negative 1. And then union, and then we pick right back up, though, after that negative 1, right? We have more graph there, so we'll go then from negative 1 to infinity here. Okay? Right? Now, do you remember, we talked about the sum yesterday, why do we have a problem at -1? Now, obviously, you can see it in the graph here, right? We have a vertical asymptote. How does that show up in our function, though? Why, if you look at the function, right, what's going to happen if we try and plug -1 into this function? Braylon? Okay, it's more than, yeah, so something like that. It's not going to be real. Yeah, so imagine plugging -1 in here. Okay, what are we going to get in the denominator? If I plug -1 in for x, what am I going to get in the denominator? 0. Right, we're going to divide by 0. Exactly right. So that's why that, and so then that connects to this idea here. We have a vertical asymptote, right? It shows up visually as a vertical asymptote. Okay, that not being able to have -1. So did we have to graph this function to determine its domain? Do we have to graph it? We don't. Right? We can assume, we can start off by assuming this function, okay, has a domain of all real numbers, -infinity to infinity, and then we need to look at its denominator for any places where it could be 0. Right? So in this case, if x was -1, my denominator would be 0, and so therefore I have to exclude it, I have to take it out of my domain. Right? So let's try another one here. Okay, so let's talk about f of x equals, let me just pick another one, x minus 4 over x plus 1 times x minus 1. Okay? So, can anyone figure out what numbers are going to give us problems in this function without looking at your graphing calculator? Anyone want to take a guess? 4? Is it okay to have a 0 in my numerator? Can I have 0 in the numerator of my fraction?
Oh, -1.
So, okay, right. -1. -1 is going to give us a problem because when I plug -1 in here, I'm going to have -1 plus 1. That'll give me a 0, and so the whole denominator will be 0. And can we divide by 0?
Nope.
No. Okay, so we're going to have to exclude -1. Is there any other x value we'll have to exclude?
-4. Wait, no.
No, -4 is going to be okay.
-4.
So -1 doesn't work. There's one other x value we have to exclude here. Besides -1, we also have to exclude. Oh, this? Yeah. Sorry, I see what you're saying now. Okay, there we go.
Oh, that's a 1.
Okay. Yeah, sorry, it's a 1. That's why. My mistake. My bad handwriting. All right. So, right. So again, we're going to exclude -1. What other number we have to exclude here? But 0 times anything is going to be what?
0.
0. Okay? So it doesn't matter positive or negative. It'll be 0 at the end. So the other one will be 1. Exactly right. So the other option here, right, is if I plug in 1, right, it doesn't matter if I get, what if I plug 1 in here, I plug 1 in here, I plug 1 in here. Here it's going to give me a 0 as well. Okay? So if I put 1 in, I get 0 times that, which will still be 0 in the denominator. I'll be divided by 0. Let's check our graphing calculators and see if that's true. So we're thinking at x equals -1 and at x equals 1, we're going to have a problem, right? So let's see what happens. Be careful how you type this in your graphing calculator. Parentheses around the numerator. And then you'll have to have kind of a set of parentheses for the denominator. And then, of course, then the parentheses for the x plus 1 and the parentheses for the x minus 1. Okay? So, again, there's just heads up. There's my denominator has, so it's divide by and then parenthesis, x plus 1, close parenthesis, open parenthesis, x minus 1, close. Oops, you can't see. I'm pointing to nothing. Okay, there we go. Sorry. Okay, so my denominator, right, has one set of parentheses, then another set of parentheses for the x plus 1, right, and then the x minus 1, and then you close both sets of parentheses there and graph it. Okay, so you can see here we're looking at some more complex functions, right? Do we have a vertical asymptote there at x equals -1? Or should we exclude -1 here from x equals -1 from our domain? Look at the graph. Yes? Yeah, right. And what about our positive 1, x equals +1? Should we exclude that from the domain? Oof. All right. Better sit down for this one, I guess. Be here for a while. So -1 works, right? Right, -1, you can see it's excluded. Do you see also the x equals 1? We also need to exclude there, right? You see that vertical asymptote there at x equals 1, right? So we're going to exclude that too. Okay. So our domain then is going to be -infinity to -1, right? Union will pick back up here after the -1 though, because there's a little bit of graph right there. -1 to 1. Okay, and then we have to skip the 1, and then we pick back up at the 1, and we're going to go to infinity there. Okay, so we broke up our number line there. -infinity to -1, -1 to 1, 1 to infinity, right? We're taking out the -1, we're taking out the 1 there. All right, questions on any of that? So what do you mean by an error? Like what'd you do to get the error? Oh, like a table you're saying? Like there? One error and then -1 error? So those can be also kind of they can indicate yes that you want to take those out of your domain. You don't want to include those in your domain, yeah. They cause problems. So well, I'll show you here in a second. So let's keep working here, and I think we'll answer your question. Okay, we'll get to that. Oh, you have additional, like you have a straight line right there. So some people's calculators, for whatever reason, the calculator likes to connect it there. So in a sense, you can think of it like it's almost drawing in the asymptote for you. It's really not supposed to, but it's really just like an error with the way the calculator draws things sometimes. So yeah. But if you see that straight up and down line like that, though, Haley, that does indicate you have a vertical asymptote there, okay? All right, let's do one more here. This one I want you guys to try. All right, so let's see. Have you do. No, I don't want to do that one again. I'll just make one up, I guess. Okay, you guys go ahead and try this one. Okay, so there's one for you to try. There's your function, f of x. It's there. You can see it. Okay. I'm trying to warn you here, folks. This one is not easy. So if you're not paying attention right now, if you're not giving me 100%, difficult, okay? You're going to make this hard for yourself. This is not easy to just pick up, okay? I teach this to my pre-cal students too, and they have some difficulty with it as well. All right, so it's across. It's not they've already seen it before. That's their second time seeing it. So this is not necessarily easy stuff. So do put some effort in here. See what you come up with here. Yep, I want to put the phone away, guys. I'm serious. Okay? A lot of bad habits we got going on in here. Bad habits. Got to break those bad habits. Yep. Nope, you don't need to. Nope, you don't need to. You can find the domain here, folks. You can find the domain here using any method you want. You want to graph it. You want to just look at the function and do it too. Okay? Do you need a graphing calculator, Nick? No. Yeah, Brent. We'll see. I hope so. We're not going very fast though right now. People are already ready for the weekend.
Yeah, bro. Sucks, man. I just want to go to here, watch the
One more minute here, folks. One more minute. Let's get it done. Okay, Wyatt, what kind of numbers, what, did you find anything we're going to exclude from the domain here? Or did you find the domain, or? Nothing? All right. Brandon S., did you come up with any numbers we're going to exclude from the domain there? No? All right, let's go to Braylon. Did you come up with any numbers we're going to take out of the domain? 5 is one of them. Did you find another one? All right, so we got 5. That's one of them. All right, let's go to Samantha. Did you come up with another one? No. How about Chris? No. Let's go to Nate's not here. Julian. Sure. Negative infinity to negative 2. Union. Negative 2 to positive 5. Union. 5 to infinity. Perfect. Yes. Good job. Okay, good job there. All right. So, Braylon, good on the 5 there, right? But don't forget we also have this factor over here also in our denominator, okay, where if you put a negative 2 in, right, it would make that 0, and so the whole thing then would be divided by 0. Okay, so 5 and negative 2. Okay. We'll look at one more here, and then I'm going to expand a little bit on this stuff. All right. Oop. I don't want to get to that first yet, actually. Sorry, I'm making that a 2. Okay. Ultimately, folks, we want to be able to do this without a graphing calculator. All right? We don't want to just be able, because you can. It's not that hard to, it's not that hard to be able to just look at this and tell what numbers we have to exclude from our domain, which x values are going to give us problems, okay? So look at our function right here, right? Okay? One of the big things that we don't want to do, we don't want to divide by 0, right? We don't need the square root of negatives, right? We don't have any square roots to worry about here, so that's not going to be anything affecting us. We don't want to divide by 0, right? And so if you look here, right, we have these 2 places where we could be dividing by 0, right? What x value here will give us 0? Negative 3. Okay, so if negative 3 is plugged in here, I'm going to get 0, and then the whole denominator will be 0, and so I'll be dividing by 0, right? So negative 3 is a problem, okay? What about this? What x value here will make us divide by 0? Negative 2, okay? You shouldn't really have to graph these to figure out what your domain is, okay? We can just look at the denominator and see which x values will give us 0 in the denominator, Okay? So, in this case, right, just one more here. The domain of g of x, right, would be negative infinity to, let's see, we're going to hit negative 3 first there. And then negative 3 to negative 2, okay, because we have to go from negative 3 to negative 2. And then we go from negative 2 to infinity. Okay? Okay, again, because x cannot be negative 3, x cannot be negative 2. Okay, negative 3 would give us 0 here, which would make us 0 in the denominator. Okay, divide by 0, no good. Negative 2 here would give us 0 in the denominator. Again, no good. Okay. All right. All right. All right. Okay. Wholes versus vertical asymptotes. Okay? So all those x values that we've looked at this point, up to this point, right, they've all had vertical asymptotes at them. Okay? All these domain restrictions, all these numbers that we've taken out of our domain, right? Negative 3, negative 2 here. Here we took out negative 2 and 5. Here we took out negative 1 and 1, right? And then up here, just the negative 1, right? Okay, those are all vertical asymptotes. Guys, I don't know how to make this more emphatic, that this stuff is not easy. So not paying attention and talking and stuff like that, you're only digging your own grave, okay? I can't care for you, okay, but I still can get frustrated. And I'm starting to feel a little frustrated right now, okay? When I grade your quizzes and tests, for example, there, I get frustrated with that too. I don't know how many times, like, you guys make it so hard for yourself sometimes. It really frustrates me. I'm like, I try to spell it out as much as I possibly can. I give you reviews that are almost identical to the quizzes that I'm going to give you. Just the numbers change, and still, you guys, like, don't take it seriously. Maybe you just don't care, and that's if that's the way it is, that's the way it is. But I don't know. I care. I want you to do well, okay? If you don't want to do well, I can only care so much, though, I guess, right? I can't care for you. All right? So, back to this right here.
Can I go to the bathroom? Can you zoom in?
AJ, you need to sit right there and just wait and listen to this first. That was a really inappropriate time to ask to go to the bathroom. Okay? Do you understand why that was an inappropriate time to ask to go to the bathroom?
Yeah.
Okay, why was it inappropriate?
Because you're getting frustrated about this whole situation, I guess. And that we need understanding this.
Right, and you want to go to the bathroom right now. Does that make sense? I mean, if it's an emergency, if you got to go, you got to go.
Okay.
So, but if you can wait, it might be helpful to sit here and listen to what I have to say.
Can you zoom in? I can't really see.
And Mike, I also will say, if you can't see, there's plenty of seats up front here too.
Yeah.
Whole front row, okay? Or you can get some glasses too. But I'll zoom in for right now, okay? It's very clear what the priority is in this class, and that's not sitting near to whoever is trying to teach you guys to help you learn this stuff and pass the class. Okay? So anyway, wholes versus vertical asymptotes, okay? Both come from domain restrictions. come from your domain restrictions. Okay? The difference is this. Okay? If plugging in the x value gives you 0 over 0 like that, then there is a hole at that x value, not a vertical asymptote. Okay? If plugging in the x value gives you a number divided by 0, so let's just say a non-zero number. Okay. So if it gives you a number divided by 0, okay, then there is a vertical asymptote. At that x value. Okay. So let me give you an example here. Okay. We're going to identify any holes or vertical asymptotes. All right, and here's the example. Yeah, Julian. Right. So we want to be careful about just canceling stuff out here. How do I want to describe this? So our functions, yeah, that's good to see that we can cancel it out there. Okay, but how do I want to say this? If we were to cancel these two things out, the functions would be similar but not the same. Okay? Remember, what we're trying to do is to consider this whole function here. And if we start canceling things out like this, then we're kind of changing the function a little bit. And I think I'll try and get to that here in a second here. All right, so right now, okay, looking at this function, what x values are going to give us problems, right? What x values do we not want to include in our domain here? Okay, so -2, +3, okay? Because +3 again gives you 0, -2 will give you 0 there. All right? And so we want to exclude those things from our domain, okay? So x equals 3 and x equals -2. Okay? So now we're going to use what I set up here to help us kind of like identify what is a hole and what's a vertical asymptote. So plugging in the x value gives you 0 divided by 0, okay? 3 here, if you were to plug 3 into the function, right, you'd have a 0 in the numerator as well, right? 3 leads to 0 over 0, right? You get because 3 minus 3 would be 0, this whole thing would be 0, 3 minus 3 is 0, you get the whole thing 0 there. So 0 over 0, which then indicates a hole. Okay, what's that? Sure. So 2 times 3 would be 6 plus 3. That would be 9. But then when you plug the 3 in here, it would be 0. So the whole thing would be 0 in the numerator. Okay? And that's why I didn't want to cancel this out, because then we wouldn't have this domain restriction. But there is a domain restriction there. Okay? And then similarly now, if I plug in negative 2, okay, I'll get 0 in the denominator, but will I get 0 in the numerator if I plug in negative 2? Well, negative 2 minus 3 is negative 5. Negative 2 times 2 is negative 4, plus 3 is negative 1. I'm not going to get 0 in the numerator. So I'll get a number, I don't even know what I want to say here. I'll just put like divide by 0 there. Okay, so that's a vertical asymptote at x equals negative 2. Okay, so maybe it'll be better if I just show you the graph. Okay, maybe it'll just be better if I show you the graph. So, all right. So I typed it in there, and there it is, right? You'll see, right, how many vertical asymptotes do you see here in this graph? How many are there? Just one, right? But there's two numbers, right, that give us divide by 0. You see the issue here, right? 3 and negative 2 cause us to divide by 0, but only one of them ends up being a vertical asymptote, and that's at the negative 2. Okay? Why is that? Because, as Julian kind of indicated earlier, these x minus 3s, they can kind of cancel out. Okay? And so what happens at 3 then, right? We don't see any sort of like weird thing happening. Well, if you go to your table, you'll get a clue. At 3, you get an error still. Okay? And so the graph doesn't show it, but there's actually a hole in the graph right there. Okay? So vertical asymptote still exists at the negative 2 because we get divide by 0 there, right? We're dividing by 0. But there's a hole at 3, and that's because we have 0 over 0 there, that x minus 3 that can cancel, right? So that's the idea. Okay? So, questions on any of that there? Maybe do another one like that. Yeah. I guess I can just make one up. Yeah. We'll do one more here. Just make one up. Okay. Let's again just do the same thing. Find the holes / vertical asymptotes. So again, what x values here are going to give us problems? What are the x values here that we would take out of our domain? Negative 3, yeah, and negative 1. Okay, both of those are going to give us problems in our domain, right? We're going to divide by 0 in both those cases. But which one of these is going to be a hole? Which one of these is going to be a hole? The negative 1. Why? Yeah, we get 0. We're going to get a 0 in the numerator and denominator. This one leads to 0 over 0, right? Whereas at negative 3, right, we'll get 0 in the denominator, but if I plug negative 3 into either one of these, they're not going to give me 0. So I'll just have something over 0. So this indicates we have a hole at x equals negative 1, and this indicates that we have a vertical asymptote at x equals negative 3. Okay, so two different ways to designate those domain restrictions there. Okay, and if I show you the graph of this one, okay, the problem with the graphing calculator here is that it doesn't really show holes well. Okay, so you don't want to rely on using the graphing calculator to show you those holes. All right, there's that vertical asymptote at negative 3, right? But we see here at negative 1, there's no indication there's a hole there. But if you go to your table, you'll see that at negative 1, we still get that error message, okay, in the table. Okay? me see here. So here's what I'm gonna have you guys do, since we didn't get as far as I wanted to here. Actually, we can still do some stuff, I think, yeah. Yeah, I'll get your quiz back, yes, I'll get those back here too. Okay, so here's what we'll do. We'll stop there, all right? I'll just give you guys some practice with those for your assignment here, all right? Should have time to work on it here to get some practice in. Okay, so, oh, not page 411, sorry, that is on the wrong thing. All right, AJ, if you want to hit the bathroom now, feel free. All right, thank you for waiting. All right, sorry, page 300, which is section 8-2. All right, I would like you to try. Numbers 1 through 3. And seven. Okay. 1 through 3 and number 7. Okay. Number 3 asks you to do long division there, okay, to rewrite the function. And then determine the function's end behavior. Then you can use your graphing calculator. I mean, basically, just what I say is make sure you read the directions there, because there's just a couple things that it's asking you to do, and I do want you to do all the things that are there. Don't worry about stating the range as inequality. So just use interval notation, I guess is what I'll say. Okay. So for number 3, just use interval notation for the range.